Alright, so the first step we created is a marble chute, designed with a holding place for the marbles, which are released when a tab is pulled. This step demonstrates gravity and free fall, as the marbles fall straight down the tube once nothing is holding them up anymore.
The second step is a pulley system. When the marbles fall out of the chute into the cup on one side, the other side lifts up. As the cup moves up, it will trigger the next step, a zip line.
When the cup hits the zip line, it sets it into motion. The action of the zip line moving down demonstrates Newton's second law of motion, which states that a force on an object is equal to its mass times its acceleration. Because we know that the force of tension is present in the stretched cord, and that the mass and acceleration due to gravity pull the object towards the ground, we can draw a free body diagram of the forces on the zip line, which is shown here.
When the zip line reaches the bottom of the cord, it will hit the car, setting it in motion. The movement of the car shows the conservation of energy. As you can see, the track the car is on is similar to the roller coaster problems we did earlier this year. Before the car is hit, it is stationary at the top of the track, meaning that it has no kinetic energy, but lots of potential energy. As it moves down the track, the potential energy is converted into kinetic energy.
As the car continues on the track, it hits the marble and it stops while the marble begins moving. This is an example of the conservation of momentum. The momentum of the moving car is transferred to the marble when they hit, and the marble will move faster because it is smaller.
The marble rolls and hits the set of dominoes. Each domino hits the next domino, showing Newton's third law. Every action has an equal and opposite reaction. Each domino hits the next one, moving it, which hits the next one, moving it, and so on and so on.
When the dominoes fall down, the final domino will hit the seesaw or lever that we made. A roll of tape is on the lower side of the seesaw, and when the dominoes fall, they will hit the other side, bringing the tape up and causing it to roll down, just as you saw. This is an example of Newton's first law of motion, that an object in motion will stay in motion, and an object at rest will stay at rest unless acted upon by another force.
On the lower side of the seesaw, the tape will stay still and will not move. When the force of gravity acts on it as the lever is raised, it will move until something else stops it.
When the tape rolls, it comes up to this next section where it hits a string. This string is connected to a popsicle stick, and when the string is hit, the popsicle stick is pulled out.
After the ball is released, it rolls down and hits another ball, and each ball rolls around each side of the track. At the bottom of the round track, the balls hit again. When they hit here, they demonstrate the conservation of momentum in the form of two-dimensional momentum. This can be seen because they have the same mass, and as they hit each other at an angle, they will transfer momentum and go in the other direction, also at an angle.
As the balls hit each other, they will also tap a row of dominoes, setting it into motion. The final domino will pull out a block, which will release this rubber band catapult that we made. The catapult shows the conservation of energy because it uses elastic potential energy to function. Before it is released, the rubber bands are stretched, full of elastic potential energy. When the catapult is released, the potential energy is released and transformed into kinetic energy. The catapult shoots the marble into the air.
The flying marble hits a balloon on the ground. Since the balloon is attached to the ground, when it is hit, it will begin to vibrate quickly in an oscillating motion, acting similar to simple harmonic motion. The oscillating balloon will set off another line of dominoes when it moves back and forth.
The trail of dominoes leads to a car on an inclined plane. Using the conservation of momentum, the car will start moving when the domino hits it, and this will hit a switch on the power generator. When the car hits the switch, the generator takes its stored energy and converts it into magnetic energy. This forces the metal tube on the rod to move from one side to the other by reversing the poles of the magnets. When the tube moves across the rod, the string attached to the tube pulls the switch on the record player. The switch then drops the needle onto the record player and plays the record. It pulls this lever on here, and it puts the needle on the record and turns it on.
And that's our Rube Goldberg!